Hi everyone. Today we'll continue with the chapter 3, first order of system LDE. Okay, today we will study on the non-homogeneous system of LDE. Okay, so previously you have learned what is a homogeneous system of LDE, but what is homogeneous and what is non-homogeneous? Do you still remember? Okay, I give you an example of what is homogeneous and what is non-homogeneous. All right, so if you look at this one, y1 prime equal to 2y1 plus y2. So this one we consider as homogeneous. But let's say if non-homogeneous, there would be plus or minus with exponent x. So this exponent or whatever value may be just a number 9. So this one we'll consider as a non-homogeneous. Okay. So today we will learn how to solve this kind of non-homogeneous system. Okay. In order to solve the non-homogeneous system, in this lecture we'll teach you how to solve using the method of undetermined coefficient. Okay, now class. Let's look at the example. Example 3.6. Find the general solution and particular solution of the following non-homogeneous system of first order LDE. So you have the y1 prime equal to negative 3y1 plus y2 minus 6 exponent power of negative 2x. And y2 prime equal to y1 minus 3y2 plus 2 exponent negative 2x. And the given initial condition is y0 equal to 1 and negative 1. Okay, so you need to use the method of undetermined coefficient. Class, so how to do it? Okay, let's do it together. So first of all, you need to find the general solution of YC, okay? So find the general solution of YC. So in order to find the YC, I think the previous example you have learned on how to convert the first order differential equation into a metric form first. So you have the metric form of y prime equal to ay plus g. Okay, in the previous for the homogeneous, you know that the y prime is equal to ay, but for the non-homogeneous, it is plus g because for the non-homogeneous part. Okay, so let's convert this equation into this metric form. Okay, so now you have what? You have negative 3, 1, 1, and negative 3. So let's confirm negative 3, 1, 1, and negative 3. Y plus G. So this G, this one will be your G value. Okay, so negative 6 exponent negative 2x and 2 exponent negative 2x. So this is the metric form. Okay. The second one is you need to find the eigenvalue. Okay, so based on the A here, you have negative 3, you minus lambda. 1, 1, and negative 3 minus lambda. So based on this value, you can find the eigenvalue. Negative 3, negative lambda, multiply with negative 3, negative lambda, minus with 1 and 1. This like this. Okay? So this one you multiply in. So you get 9 plus 3 lambda plus 3 lambda plus lambda square. And then with minus 1 equal to 0. So after you simplify, you get lambda square plus 6 lambda plus 8 equal to 0, and you factorize it, you get lambda plus 4 and lambda plus 2. So you will get lambda equal to -4 and lambda equal to -2. Okay, so this is the eigenvalue. So from the eigenvalue, you need to find the eigenvector. So for lambda equal to -4, okay, based on this one, so you find out negative, you substitute the value of lambda, so -4 plus -3 plus 4, 1, 1, -3 plus 4. So -3 plus 4, you get +1. So 1 times with the x, you get x. So you get x. And then 1 times y, you get y equals 0. Similarly to here, the lower part. So 1 times x, you get x, plus 1 times y, you get y equals 0. Then you assume x is equal to s. Now is s plus y equal to 0. Now y equal to -s. So from here you know that your eigenvector is actually x and y, right? The x is 1, your y is -s. So -1s. Okay, class, do you understand? Now we shall continue. To next one is to find the lambda equal to -2. For lambda equal to -2, so -3 plus 2, 1, 1, -3 plus 2. Okay, so -3 plus 2, you get -1 times with x, so you get -x plus y equals 0, and another one also the same, x plus x minus -3 plus 2, you get -1 times with y, so -y equals 0. Then you assume the x is equal to s, then you get you substitute in -s plus y equal to 0, so y equal to s. Again, the eigenvector for this lambda equal to -2 is x is 1, y also 1s. Okay, the next step should be you have to test whether it's linearly independent or not. So you test for the eigenvector. So the first eigenvector is 1, -1. Okay, and then it's 1 and 1. All right. So you test it, 1, -1, 1 and 1. So this is to test the eigenvector is linearly independent or not. So okay, from here, your 1 times with 1 minus with 1 multiply with -1. So you will get 2. Yes, correct. Which is not equal to 0. So this means that this is linearly independent. So what's the next step, class? Okay, next step is to find the general solution as you learned in the previous example, the homogeneous system. Okay, so your YCX is C1, and then vector 1 and 1, and 1, 2 is 1, -1, this one. 1, -1. Exponent -4x plus C2, 1 and 1. So this 1 and 1 is here. Okay? Exponent -2x. So basically, this is for the homogeneous part. We only done for the homogeneous. Since this question is non-homogeneous, so we need to find the particular integral, which is called yp for the non-homogeneous. So only for the non-homogeneous system, only we need to find the yp. Okay. So part 2. So just now is the part 1. Now is the part 2. Okay. So this is the part 1. Now is the part 2. Part 1 is a homogeneous. Part 2 is a non-homogeneous. Okay. So for the part 2, you need to assume the yp. Assume the yp. Okay, what is your g value? G, okay, from the question is negative 6 exponent negative 2x and 2 exponent negative 2x. All right. And then you need to assume. This one is you need to refer a table. So this table you can refer to page 79. Okay. Or okay, 79 is like this. You need to assume the yp based on the g value. Okay. So your g value is negative 6 exponent and 2 exponent. So this case, what is the case? Case 1, 2, or 3? Yes, it's a case exponent, right? It's a case exponent. So case exponent, if you look at here, case exponent is yp is equal to u1, u2, or you will name it as a mu1, mu2, exponent negative 2x. The lambda is negative 2 lah, because we have the lambda is negative 2. Okay, so your assume yp is equal to u1, u2, exponent negative 2x. So you check again, this u1, u2 exponent negative 2x is same with yc or not? What is your yc? This is your yc. Is it same with the yc? Yc have the exponent. Okay, whether yp also got exponent? If he has exponent 2x, here also have exponent 2x. So means it's the same. Okay, so this yp is the same with yc. So cannot. If yp same with the yc cannot, so we need to assume a new yp. New yp. So you need to assume for new yp. So this is equal to u1x plus v1, u2x plus v2, and then multiply with exponent negative 2x. And then you check again. This new yp is the same with the yc? Okay, it's not the same. It's not the same, then this is your latest yp value. Once you get the yp value, you need to find the yp prime based on the new yp. Okay. So I assume this part is u, and I assume this part is v. So we do the differentiation. So we assume the u is exponent negative 2x. So u prime, okay, correct, negative 2 exponent negative 2x. And v is u1 x plus v1, u2x plus v2. So v prime is equal to u1, u2. Yes, correct. So based on the formula, uv prime plus vu prime, in order to do the differentiation, you use the formula uv prime plus vu prime. So you just substitute the value. u is exponent negative 2x. V prime is u1, u2, plus v is u1x plus v1, u2x plus v2. And then u prime is negative 2 exponent negative 2x. Okay. So this is your yp prime. Okay, so this is your yp prime. Okay, shall we continue? Okay, after you get yp and yp prime, you can compare. Next step is to compare the yp prime with the y prime. So third, compare the yp prime with y prime. Okay, so yp prime equal to y prime. Y prime actually is from the early early question. You have y prime equal to ay plus g. Do you still remember? Okay, so you can substitute. All right, you substitute in this yp prime. So you get u1, u2 exponent negative 2x minus, okay, u1, u2 minus with 2, right? Minus with 2 u1x plus v1, u2x plus v2, and then this one is for exponent 2x, negative 2x. Okay. And then equal to a. A from the previous is you obtain negative 3, 1, 1, negative 3. And then y plus g, right? G is negative 6 exponent negative 2x and 2 exponent negative 2x. Okay. Now what is this y? This y actually is referred to the yp. This y actually is referred to the yp. Okay. So I continue again, equal to negative 3, 1, 1, negative 3. u1x plus v1, u2x plus v2, exponent negative 2x, plus with negative 6, exponent negative 2x, 2 exponent negative 2x. Okay, now you can collect all the exponent. Okay, collect all the exponent. For example, this exponent and this exponent, you collect everything. So left hand side is left hand side, right hand side is right hand side. So you collect all the things into one. So you have u1 minus 2u1x minus 2v, or plus, no, minus 2v1. u2 minus 2u2x minus 2v2. Okay, so this part is for the exponent negative 2x equal to okay, here also have exponent negative 2x okay, then it should be equal to, so you have the exponent and exponent here, so you just combine the exponent. Okay, can you solve this one first? Okay, this one we multiply in first, so negative 3 This one you multiply with this. Okay, negative 3 u1x minus 3v1 plus u2x plus v2, and then the second row is u1x plus v1 minus 3u2x minus 3v2. So this one is for the exponent, negative 2x. Okay. So now it's more clearer. You can just solve it. Class, if you look at here, you see you have u1, negative 2u1x. And then this one, oh, okay. So if you look at here, you have actually is this one. Let me use different color. If you look at here, actually this one is the x. We don't want the x inside the equation. So this one also have x, also have x, x, x. So we can take it out. We can separate into two. What do you mean here is like, okay. So now you can separate the exponent power of negative 2x and the x exponent negative 2x. Alright? So you have for the x exponent negative 2x is negative 2. For this part is negative 2 u1 and negative 2 u2. So this part is the x exponent negative 2x, right? And then plus with exponent 2x. So you have this part 1 and then another one here. Okay, so you have u1 minus 2v1 and u2 minus 2v2. This is for the exponent negative 2x. Equal to, so the right hand side also the same. You get negative 3u1 plus u2, negative 3u1 plus u2, and this one. Okay, and then u1 minus 3u2 x exponent negative 2x. Then plus with this one. Negative 3v1 plus v2, and then you still have this one. Negative minus 6. And the second part is the v1 minus 3v2 plus 2. So this is exponent negative 2x. Okay. So now what is next? Next is you compare the coefficient. You compare the coefficient. Then by equating the coefficient, so by equating the coefficient of x exponent negative 2x, this one and this one. Okay, so first of all is the x exponent first. So for the x exponent, what do you have? X exponent. Okay, x exponent, you have this one for the left hand side, and the right hand side you have this one. Okay, so you have negative 2u1, negative 2u2. The left hand side, and right hand side is negative 3u1 plus u2 and u1 minus 3u2. Then you generate the equation. Negative 3u1 plus 2u1 plus u2 equals 0. Okay, for the first one. Okay, then u2, u1 minus u2. So u1 minus 3 plus 2, so you have minus 1. Minus 1 u2 equal to 0. So from here, you know that this one is u1 equal to u2. Then you assume u1 equal to s. So you substitute the value. So s minus s so this one, what do you get? Negative u1 plus u2 equal to 0. Okay. So you have from here, you get negative s. When you assume u1 equal to s, so negative s plus u2 equal to 0. So u2 equal to s. So you can get u1 and u2. Now your u1, u2 is s and s. Okay, after you compare x exponent, now you compare for the exponent. Compare exponent negative 2x. So what do you get? For the compare exponent, okay, now you have this one. For the exponent, you have this one and this one. Okay. So you have u1 minus 2v1, u2 minus 2v2 equal to negative 3v1 plus v2 minus 6, v1 minus 3, v2 plus 2. Then you assume u1 equal to s and u2 equal to s also. So s minus 2v1 and s minus 2v2. Okay. Equal to, okay, substitute the value. Negative 3, okay, v1 is, v1 remain, plus v2 minus 6, v1 minus 3, v2 plus 2. So you generate equation, negative 3v1 plus 2v1. Okay, negative 3v1 plus 2v1, okay? And then plus v2 equal to s plus 6. v1 minus 3v2 plus 2v2 equal to s minus 2. So you have two equations. So from here you get negative v1 plus v2 equal to s plus 6. So this one I name it as equation 1. So v1 minus v1 minus v2 equal to s minus 2. So v1, what do you get from e1? e1 is s minus 2 plus v2. I name it as equation 2. Then you insert the substitute the equation 2 into the equation 1. You get okay, so you just substitute this equation. You substitute into you substitute the value of v1 into here. So you have negative s minus 2 plus v2 equal to s plus 6. So you simplify it. Alright. So you get negative s negative s is negative 2s equal to 6 minus 2 is 4. So s equal to negative 2. So this is equation number 3, in which the s is equal to negative 2. So you substitute the value of s equal to negative 2 into the equation 2. So v1 equal to negative 2, and minus 2 plus v2. So v1 minus v2 is equal to negative 4. Then assume again v1 equal to s. Then s minus v2 is equal to negative 4. v2 is s plus 4. So now your v1, v2 is s plus 4. So your yp value is u1x plus v1, u2x plus v2, exponent negative 2x. So you substitute the value of u1, u2. u1, u2. So from the previous, you obtain u1, u2, right? Yep, u1, u2 is 1, 1. 1, 1. Plus v1, v2 is s and s plus 4 here. So is s plus 4 exponent negative 2x. All right. Okay, from the previous, you know that the s is equal to negative 2. Okay, you know that s is equal to negative 2. So you substitute the value. So since s is equal to negative 2, yp is equal to negative 2x minus 2, negative 2x plus negative 2 plus 4, exponent negative 2x. So this will result in negative 2x, negative 2, negative 2x plus 2, exponent negative 2x. Okay, so actually it's a continue. You just substitute the value only. Okay, so this is the YP. Part YC you have done. Part 1 is a YC. Part 2 is a YP. Then part 3 is the general solution. So part 3 is the general solution. Y equal to YC plus YP. C1, your vector is 1, negative 1. Plus C2. And then YP plus with negative 2x, negative 2, negative 2x plus 2, exponent negative 2x. So part 4 will be, you have to substitute the value for the initial condition. So when x is equal to 0, y1 equal to 1, and y2 equal to negative 1. So you just substitute a value for the general solution. 1, negative 1. Okay, you substitute the value of x equals 0, y1 equal to 1, y2 equal to negative 1. Okay, from here you have you can generate 3 equation. Okay, one So you have 1 equal to C1. C1, okay, this one is 1. C1 plus this one is C2. You have minus 2. So minus 2 you bring back to equals to plus 2, okay? So this is equation 1. So for the second one, so you have negative 1, so you plus 2, you bring to the left hand side is the negative 2 or minus 2, equal to negative C1 plus C2. So this is equation number 2. So the first one will result in what? C1 plus C2. So you make it C1 equal to this 1 plus 2 is 3. So 3 minus C2. This is equation 3. So you insert the equation 3 into the equation 2. Equation 3 is this one. Equation 2 is this one. Okay, you insert in or substitute it. You will get this value. Negative 3 equal to negative 3 plus 2 C2. And then C2 is equal to negative 3 plus 3 is 0. So C2 is 0. So this is the fourth equation. So C2 is 0. So what is the C1 value? C1 is 3 minus C2. So 3 minus C2, this means it is equal to 3. Now almost towards the end, the final general solution is y equal to C1. So C1, you know the value, right? Plus C2. Okay. Oh, straight away we can write down the answer. Okay, C1 is 3. C2 is 0. C2 is 0, so this one no need. So the plus with the last part. Okay, so this is the final answer. For the question of non-homogeneous is a bit long, so a few pages. Hopefully you can more patient to look into this question. So thank you for watching and hope you enjoy. Bye.